Alright, so let's go over some show your work questions. Let's start with number 1. This is a no calculator question. The function f is defined by f of x, which is equal to the square root of 25 minus x squared from negative 5 to 5. Well, you don't need to know this, but it may help to know that the square root of 25 minus x squared is the top of a circle. That sort of visual helps you confirm all the answers in case you're not sure whether you got the right answer or not. So, first thing says find f prime of x. So looking for the derivative. Since we're looking for the derivative of square root of 25 minus x squared, I'm definitely going to rewrite this as 25 minus x squared to the 1/2 power. Using chain rule and power rule, 1/2 times 25 minus x squared, and then subtract 1, so you get negative 1/2. Now what we can do is take the derivative of the inside. Well, the derivative of 25 is 0, and the derivative of negative x squared is negative 2x. If you really wanted to go about simplifying this, you would get 1/2 and negative 2 cancel each other out. So I'm left with negative x over the square root of 25 minus x squared. You don't need to, but it may help for later calculations. B. Write an equation for the line tangent to the graph of f at x equals 3. Always, always, always make sure you're able to show these two things. You're looking for the point and the slope. If you don't state that you actually found the point and slope from these numbers, you won't get the credit. So, f of negative 3, plug negative 3 into the original. 25 minus negative 3 squared. 25 minus 9 is 16. Square root of 16 is 4. Not plus or minus 4, just 4. For the slope, we'll be plugging in negative 3 into the derivative. So that would be the opposite of negative 3 over, and then 25 minus, and I'm going to clean this up, negative 3 squared is just 9. So then this becomes 3/4. So the slope of or the equation of the tangent line would be y minus 4 equals 3/4 x plus 3. Part C, use the tangent line approximation to approximate f of negative 2.9. Is this approximation under or over? Well, it's not that bad, because if you remember, we get this very specific form. F of x is approximately f of a plus f prime of a x minus a. That's just taking this original equation of the tangent line and just adding the 4 over. So really, this looks like this. F of x is approximately 4 plus 3/4 x plus 3. And we're approximating f of negative 2.9. So negative 2.9 plus 3 is positive 0.1 times 3/4 is 0.075 plus 4 equals 4.075. There you go. Now, is the approximation over or under approximation? There is no other way for you to justify this besides using the second derivative. You can say you know what the picture looks like, but that does not cut it. You have to use the second derivative. Well, if the first derivative, I'm going to rewrite it here, was negative x over square root of 25 minus x squared, I can do quotient rule. I can do many things here, but I'm actually going to change this for a second. I'm going to write negative x times 25 minus x squared to the negative 1/2. Simply so I can use the product rule instead of using the quotient rule. Sometimes it helps, sometimes it doesn't. I simply prefer, this is my preference. F double prime of x would equal, keep negative x the same, take the derivative of 25 minus x squared to the negative 1/2. So that'll be, put a negative 1/2 in front. 25 minus x squared to the negative 3/2 times the derivative of the inside, which is negative 2x. Plus, and I'm running out of space, what's the derivative of, or this time, keep 25 minus x squared to the negative 1/2 the same. 25 minus x squared to the negative 1/2 the same. But what's the derivative of negative x? That'll be negative 1. You can simplify here, but in this case, it's not necessary. All I have to do is be able to tell what the concavity of the graph is at, and this is where you gotta be careful, negative 3, not negative 2.9. F double prime of negative 3, because our tangent line is touching our graph at negative 3. So we're curious to know that if I have a curve and a line, is the line bending away and down from the graph or away and up from the graph? This tells me whether it's an over or under approximation. So we have to plug in negative 3. Well, piece by piece, let's see what happens. This becomes a 3. This stays as negative 1/2. This becomes 25 minus negative 3 squared. Well, so it's the same thing as before. So we'll get 16 to the negative 3/2. And then negative 2 times negative 3 is 6. Plus, this is again 25 minus 9. So that means 16 to the negative 1/2 times negative 1. Now, this is where it becomes very, very easy. This entire number is negative because I can see 3 is positive, negative 1/2 is negative, 16 is positive, 6 is positive. This number is also negative because 16 to the negative 1/2 is positive and negative 1 is negative. That means I'm adding two negative numbers. All that means and all that I care about is that this is less than 0. So, since f double prime of negative 3 is less than 0, f is concave down at x equals negative 3. I'm going to squeeze this in right here. And therefore, our answer is n. Well, be careful because if it's concave down, that means the tangent line is always above. Therefore, an over approximation. Some people on their AP packets, all they did was show the second derivative and then jump to this conclusion. You really have to show some effort of being able to find out whether the answer is positive or negative. And it's as simple as just plugging in 3 and then being able to conclude that it's negative. All right. For part D, let g be the function f of x, which is from above, between negative 5 and negative 3, and x plus 7 everywhere else. Is g continuous at x equals negative 3? Continuity, we know we have to use limits, and it even tells you use definition of continuity. Limit of g of x as x approaches negative 3 from the left. The limit of g of x as x approaches negative 3 from the right. And simply, what is g of negative 3? Well, if we're going to be using g of x from the left side of negative 3, we're actually using f of negative 3, which we've calculated multiple times from before, is 4. G of x as x approaches negative 3 from the top, so we're going to be using the x plus 7, but plugging in negative 3 plus 7 is 4. And then finally, what is g of negative 3? Well, at negative 3, I use the top function. So it's just, again, what is f of negative 3? And that's 4. Since, not f, since g of negative 3 equals the limit of g of x, sorry that cut off, as x approaches negative 3, g is continuous at x equals negative 3. Very simple as long as you know the definition of continuity. Okay, for the last part, determine the concavity of g of x at x equals negative 4. So I need g double prime of negative 4. That's our goal right now. If it's positive, it's concave up. If it's negative, it's concave down. Well, g double prime, since I'm looking at x equals negative 4, I'm really looking at the interval between negative 5 and negative 3. So the nice thing is the second derivative of f of x is going to be the same answer I got in part B. That ugly answer, which was right here, I get to use that. So what I'm going to do is I'm going to copy that answer down here. And I think I undid it. See if I can get it. Doesn't look like it. Okay. I'm just going to have to copy it down. Negative x, negative 1/2, 25 minus x squared to the negative 3/2 times negative 2x plus 25 minus x squared to the negative 1/2 times negative 1. Let's plug in negative 4, and we'll get 4 negative 1/2. This is going to be 25 minus 16 because negative 4 squared is 16, so 25 minus 16 is 9. So this is 9 to the negative 3/2, and negative 2 times negative 4 is positive 8. Same thing right here, 25 minus x squared is also going to be 9 to the negative 1/2 times negative 1. Using the exact same logic from before, I know this is negative. So since g double prime of negative 4 is less than 0, g of x is concave down at x equals negative 4.